Okay, Bismillah Rahman Rahim. Voltage doubler circuit. Okay, so actually our topic is generating the HVDC. Okay, high voltage DC generation. This is actually our topic, high voltage DC generation. Okay, so first we will start with the voltage doubler circuit because this is the single unit of this HVDC. Okay, then we will switch to the multiplier circuit. Okay, and this multiplier circuit is designed by two scientists, the Walton and Cockcroft. So that is why it is named as the Walton Cockcroft multiplier circuit for the high voltage DC generation. Okay, but the single unit of this Walton Cockcroft generator is voltage doubler circuit. So that's why we will start with the very beginning of this high voltage DC generator. Okay, so voltage doubler circuit, as the name reveals, that the output of the circuit is the double of the input. Okay, so how it become double? Okay, there are so many circuits. The tripler voltage tripler circuit also exists. Voltage quadrupler circuits are also exist. So the phenomena is the same. Okay, the mechanism is the same. So there are two types of the voltage doubler circuit. This may be formed with the half wave rectifier and with the full wave rectifier. So we will explain it through the full wave rectifier. Okay, so this is the circuit of full wave rectifier. Okay, so let's start with the first half cycle of the input. Okay, then we will explain the second half cycle of the circuit, the input. So then we will study the combined effect of these two. Okay, so this is the first half cycle, the transformer. Okay, so the AC, this is the positive, this is the negative. Okay, and these arrows show the uh, motion or the flow of the current. Okay, so when this when the current flowing through the D1 diode, so it will be forward biased. Okay, so forward bias means the diode will act as a short circuit. So we can represent it by a short circuit as well. Short circuit. Okay, straight line. Okay, so when the current move through the capacitor, so the charges will be accumulated, stored or stored on this capacitor C1. So okay, you must know that in full wave bridge rectifier circuit, we must have two diodes. Okay, and two capacitors. Okay, and we will get the output from here. Okay, this is the V output. Okay, so and the voltage, the peak value of the first half cycle is Vs maximum. Vs represent the voltage source. Okay, so Vs maximum is the peak value of the single mm, first half cycle. Okay, so due to the first half cycle, the current, as the current is flowing through it, so the capacitor will be charged to Vs maximum, this peak value. Okay, now mm, okay, now so this current will move to this, not through this way, because for this current, this will act as a reverse bias. Okay, so D2 will be a reverse bias. So reverse bias means it will act as a open circuit for the current. Okay, so as we know that current cannot flow through the open circuit. Through the open circuit, I is, R is equal to 0. So it will not follow this path, rather it will move through this way, okay, and completes its first half cycle. So now when we have the second half cycle, okay, so now this become positive and this is negative, okay. So now d2 will be forwarded bias and d1 will be reverse bias. So it means d2 will acts as a short circuit for the current flow, and d1 will acts as a mm, open circuit, okay. So the current will move through this direction, okay, this, okay, this, 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 and then this, not flowing to this, because this will be uh, the reverse bias, okay. if we if this current wants to flow through this direction, so it will be reverse bias, okay. So it will follow this path, okay. So now the capacitor, this C2, is charged to Vs maximum again, because the peak value of the negative half cycle is also Vs maximum, and this negative shows just the current direction, or the is reversed from the first one, okay. The first one was clockwise, then this is now you can see the anti-clockwise, okay. So but the this capacitor is connected to, this plate is connected to the negative side, and this is connected to the positive side. So the same charges will be appears as in C1, okay, and same voltage. So now we have after one half cycle, if we want to get the output, so the output will be Vs maximum plus Vs maximum, because these two are in reinforced mode, okay. So plus minus, it adds, okay. So Vc1, the voltage appears across the capacitor C1, plus Vc2 voltage appeared across the capacitor C2, is equal to Vs maximum plus Vs maximum, which is equal to 2 Vs maximum. So 2 Vs maximum means it doubles the voltage, okay. So by this way we get the 2 Vs maximum after one complete half cycle, okay. So voltage multiplier circuit, okay. So this is the single unit of the voltage multiplier circuit, which is also a voltage doubler circuit, but now the 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 connection is little bit different. This is the similar voltage doubler circuit. It also gives us the mm, v v2 vs maximum, just like in the previous case, but now we are getting the output from the capacitor C2. In this case the output uh, was collected from both of C1 and C2, but now in this case it is a little bit different from the previous one by the connection wise, okay, but by mechanism wise it is the same, okay. So let's discuss it by the similar way, that first we will consider the first half cycle, and then we will move to the second half cycle, and then we will study what will be the output after the second half cycle, uh, after completing the full cycle, okay. So in the first half cycle, okay, the dot show that we are talking about this first half cycle, okay. So d1 ons and d2 offs, okay. D1 will be on, means it will be forward bias, and d2 will be reverse bias, okay. So d1 will be short circuited, d2 will be open circuited, and it the color also shows the same, okay. Green means on, the red means off, okay. So okay, so we can draw it as the short circuit d1 and d2 open circuit, Okay, so the current will flow just like through this direction. Okay, so positive will be appear over here, negative will be appear over here. Okay, and so in this case the vs is actually v, the peak value is now v, m means v maximum. Okay, so vm, so the capacitor c1 will be charged up to vm in the first half cycle. Okay, now in the second half cycle, now the dot is over here, so we are now uh, explaining the second half cycle. Okay, this was already charged in the first half cycle. Okay, now d2 will be on and d1 will be off. Okay, so it will be open circuit now in the second half cycle, and it will be short circuited. Okay, so the current will move through this, because now this is plus, this is minus. Okay, so as this is also minus plus minus plus, okay, by KCL you can also find the voltage through the capacitor, because this is a single loop. Okay, this is open circuit, so now the open loop the loop is like this. Okay, so v in is the source. Okay, minus vc2 plus vm. Okay, from either side you can find the kvl. Okay, they started through this direction. Okay, plus vn, now plus vm minus vc2. Okay, plus vn plus vm minus vc2 is equal to 0. So if you want to find the vc2, so adding vc2 on both sides, you will get vc2 is equal to vin plus vm. So vin is actually uh, the peak value of the vn is vm. So vm plus vm is equal to vc2. So vc2 will be equal to 2vm, means the output after the complete half cycle through the capacitor c2 will be 2vm. Okay, so this is the now again the voltage doubler circuit, because it doubles the voltage. Okay, but now we are getting the output across the capacitor c2. Okay, because this charge and this charge, both of these two will add up, and the current from these two will combinedly flowing through this capacitor c2. Okay, so the charge now will appear vm, both of these two. Okay, now voltage tripler circuit. Okay, and voltage quadrupler circuit. So c1 c2 d1 d2, now c3 c4 d3 d4. Okay, so now we will get the output across the c4. Okay, c4. So okay, this is the Cockcroft Walton voltage multiplier circuit. Okay, voltage doubler operation. uh, this is the whole figure is actually the Cockcroft Walton voltage multiplier circuit, but the single unit of this multiplier circuit, which is uh, shown by this blue surrounded with this blue purple line. This is actually the voltage doubler circuit, which I have already told you that this is the single unit of this voltage multiplier circuit. Okay, so look, we have the c1 c2 d1 and d2, the same mechanism as I have explained in the previous slides over here. Okay, so the rectifier D1, D2, capacitor C1, C2, and transformer T forms the voltage doubler circuit. The higher voltages of 4, 6 up to 2n times the input voltage can be obtained using n stage connected in series. Okay, so uh, look, we have uh, D3, D4, C3, C4, then D5, D6, C3, C5, C6 up till uh, D2N, C2N. Okay, this is the even diode and even capacitor. And the second last one is, which is the odd one, which is D2N minus 1, C2N minus 1. Okay, so you can get any value by putting the n value. Okay, if n is equal to 10, so means we have d2 into 10 means d20, c20, d19, c19. Okay, so the higher voltage operation, for the higher voltage operation, the rectifiers d1, d3, d2 and minus 1 conducts during negative half cycle. Okay, and the odd diodes, okay, represented by the odd numbers. Okay, so this will conduct during the negative half cycle, just like we have studied in d1. And the rectifiers d2, d4 up till d2 and conducts during positive half cycle, means the even, the diodes represented with the even number. Okay, so the negative halves, the diodes with odd number that are conducted in the negative half cycle are represented with the red color. Okay, and those having the serial number of the even and which conducts in positive half cycle are colored with green. Okay, this is the output of the voltage multiplier circuit. Okay, represented by the dotted lines. So the output during the negative half cycle is C2 and minus 1 is this, and this is the output of the C2n. Okay, and this is actually the mean value. Okay, the average value. And the solid, the sinusoidal waveform represented with the solid lines are actually the input. Okay, so you can see that the the output is a little bit smaller than the peak value of the input. Okay, these are because of the some losses. Okay, there might be some ripples in the output voltage. Okay, because we will not get the pure sinusoidal. So if you want to find the ripple voltage, okay, so this sigma actually represent the ripple voltage. Okay, so ripple voltage will be equal to IL over f c dot n into n plus 1 divided by 2. N represents the number of stages of the generator. Okay, f is the frequency of the supply voltage, c is the capacitance. Okay, IL is the load current from the rectifier. Putting these values, you will get the ripple voltage. Okay, now if you want to voltage regulation or the voltage drop, which actually appears over here. Okay, this is the voltage drop. So it is represented by delta V is equal to IL, the same variables but different equation. IL F C 2 to 2 over 3 n cube plus n square over 2 minus n over 6. N represents the stage, the number of stage. Okay, if we have the 10 stage generator, so n will be equal to 10. IL the load current, F is the frequency of the supply voltage, C is the capacitance. Okay, so the optimum number of stages for minimum voltage drop. Okay, so the minimum voltage drop for the optimum number of stages will be, can be found by this, where V maximum is the peak rated transformer secondary voltage. Okay, so this is the summary of the whole lecture. To obtain the maximum output from n stages, the output of the n stage generator will be 2n V maximum. Okay, so if we have a single unit, for example the voltage doubler circuit, so n will be in the voltage doubler circuit. Voltage doubler circuit is the single unit, so it means n is equal to 1. So if we put n is equal to 1, so output of the voltage doubler circuit will be 2 V maximum. Okay, to obtain the economical circuit, uses high frequency. Okay, the uses the high frequency to obtain the economical circuit. And if you want to have a minimum ripples, so use the low values for the capacitance. Okay, if you use the low capacitance values, so minimum ripple will occur in the output of that voltage multiplier circuit. So that was all about the voltage doubler circuit. Hope you will understand it. Thank you.